Thanks for the feedback. If you just joined us, it is CSTSUG for both Facebook and Twitter. Now back to the lesson. We're still learning alternating and direct currents, and possibly learning their uses and their forms. We'll see you right after this.
Welcome back from the short break. Before I move on to explain something on the direct current generator, I want to look at the application of the alternating current generator. Most of us have seen some structures on the hind wheels of bicycles, which we call dynamos, as we are going to see in that animation. It consists of the same arrangement, the coil and the magnets arranged in such a way that in this case the magnet is the one rotating and the coil is stationary. So we can have either the coil rotating in between the poles of a magnet, or you can have the magnet rotating in the coil. The same current will be induced. Now in this case the magnet is cylindrical and the coil is outside the magnet, but the same effect is produced when the coil starts rotating. When the magnet starts rotating. Now what makes the magnet to begin rotating? As you are riding the bicycle, you make sure that if you want to use the lamp on the bicycle, then you press that part there so that it touches the wheel of the bicycle. And as it touches the wheel of the bicycle, as the wheel turns, it makes that part rotate and therefore makes the magnet inside the dynamo also to rotate. And thus current will be induced in the coil, and then we shall have our lamp giving us light when you are riding the bicycle at night. And that is one of a very important application of this alternating current generator. That is why at times we refer to it as a dynamo. We can say an alternating current generator, or we can refer to it also as a dynamo. After looking at the AC generator, I said we also have to use the same setup to produce DC or direct current by the direct current generator. Now the only difference between direct current generator and the alternating current generator is that while the alternating current generator has a slip ring or slip rings, the direct current generator has got the commutators, as you can see. It has as if it is one ring but split into two. Those ones we call them generators, and they are touching against the brushes. But as the coil rotates, as you are seeing, the type of current that is produced is not the same as in the previous one. The other one we had two cycles and both of them were in different directions. While this one here, the current is in the same direction. Now let me take you back briefly to where we were the other time when we had the direct current, the alternating current generator. As you can see, the current being produced, it is in form of a sine wave, that curve. Whereas when we come to the direct current generator as seen in this diagram, the curve which is obtained is only in one direction. And that's why we say this one here is a direct current, whereas the first one was an alternating current. Now the difference between these two is that the alternating current flows to and fro in a wire, whereas the direct current flows in only one direction. That is why you are seeing with this direct current, the lower bit is not there. We are only having the flow in one direction. Even when you look at the arrows which are moving, here the arrows are moving in the same direction. But when we go briefly to the previous one, you can see that at one time the arrows are moving this way to the right, and at at another time they are moving to the left. I hope you are able to see that. I want us to pay special attention to this diagram here, where when you look at the arrows in the coil, they are moving only in one direction. Whereas when you look at the previous one with AC, at one moment the arrows are moving in one direction, and shortly they move in the opposite direction. That is an indication that the current is moving to and fro. Now, when we are teaching this topic, at times we have problems explaining why we have AC behaving in that way and DC also behaving in that way. Because you cannot draw on a board and show when electricity is moving in one direction and then also when it's moving in the opposite direction. So this animation makes it very clear. You can see the arrows are moving in one direction for DC, and for the other one, the arrows are moving in opposite directions. If you make it, for example, if you hold the movement, the arrows are in one direction. Now if you press it again, you can see that the direction changes. And that is the beauty of using the digital science. Now we have, of course, different devices using direct current, and also the different ones using AC, alternating current. For example, we have some radio sets which use only DC, direct current. And then there are those radio sets which can use both AC and DC. So that when you are plugging in the AC, they usually have a button where you switch onto AC, and if you want to use the dry cells, you put the switch into DC. So that is the beauty of using this program or this tool when we are teaching science. If you want to do some bit of revision as a student, you can also go into the quiz. Now the quiz has got two modes, the learning mode and the test mode. You are free to use the test mode or the learning mode. The answers are given and the explanations are given to the answers. For example, if you look at that question, the figure shows a coil C kept next to a wire A, and A has a constantly increasing current. Which is the correct statement? Now you can click on any of them. If you click on this one here and then you check the answer, it will tell you that that one is the correct answer. And then if you click on the explanation, then like that, it also gives you the explanation. And that is the beauty of digital science. And if you want to go to the next one, then it also gives you the same arrangement. So that is how we can use digital science to improve the learning of science, the learning and the teaching of science, because we as teachers, we find it very difficult, for example, to draw such diagrams like we have seen. And also the students cannot visualize what happens in the DC and AC generators. At times, we talk about a direct current generator, but when you go to the physical generator, the students are challenged, even the teachers, because you would see the coils inside there are not rectangular, as we say, because they are quite a number of coils. For example, when you go to a washing bay, you take your car to a washing bay and you want it to be washed. Usually you find somebody trying to pull a rope on the generator, and then as he pulls the rope, the generator starts making noise and at the same time produces current which splashes or pushes the water into the car where you want to wash. So that is the beauty of digital science. Yes, it has been nice taking you through this lesson of how we can produce current using the generators as you've seen. It is a continuation from where we had the previous lesson about electromagnetic induction. Now we went into the application, the real application of electromagnetic induction. And that is how we have ended up looking at the generators, the two types, AC and DC. So until next time, I'm Patrick, who has been your teacher of physics, and see you next time with a different topic.
Thanks for watching the show. I hope you learned a few things about the show. If you're a teacher, you'll appreciate the use of digital science and virtual lab. And if you're a student, learning is made simple and it's fun. Now remember, the show is Digital Science for You. Digital Science and Virtual Lab is a software located via Cyber School Technology Solutions via Uma Showgrounds, Lugogo. You can also follow us on Facebook and Twitter, CSTSUG. Till next time, allow me to enjoy my coffee.